Hi everyone, welcome to the next NLP Journal Club. Today we're looking at a paper called Mirror-Generative Neural Machine Translation, which will be published at ICLR 2020 in a couple of months. And it's by a bunch of authors from Nanjing University and ByteDance AI Lab. And the paper is about neural machine translation. So first of all, to give you a quick background about neural machine translation, the basic approach is, if we look at only at this part of this equation here, is that you have some input sentence x, which could be in German, let's say, and you want to translate it to target language, let's say English. And you do this by modeling the probability distribution of P of y, so the English sentence given the German sentence, and maybe some, well, that's it basically. That's how we model it. And this is done, what you do, you have some model which can learn this, and you learn this from parallel training data, so parallel sentences in English and German that have the same meaning. And given that you have some new German sentences, you can then apply your model to generate translations. But this paper is about a different approach called Mirror-Generative Neural Machine Translation, which explores a new idea of training multiple translation components simultaneously, optimizing them, so multiple translation models, optimizing them jointly in order to improve the overall performance of the translation, as well as to exploit non-parallel data, so raw data, for example, existing on Wikipedia for which you don't have translations, or raw web pages. So the question is, one of the questions is how to exploit this data to improve the translation performance. And the approach of the authors actually in this paper is they don't model the probability distribution I was talking about in the original neural machine translation, but they try to model a joint probability of the source sentence, the target sentence, given some latent variable z, and they decompose this probability in the following components. You have a source to target model, which models the probability of y, or the English sentence given the German sentence, as shown here. You also have a target to source model, which models the reverse direction, so tries to predict the most likely German sentence given the English sentence. So it's predicting the most likely input. Well, here you don't have inputs and outputs, you jointly learn from this data. And then you also have actually two language models. Language model on the target side, so models the probability of English given this latent variable, and the probability of German given this latent variable. And so this latent variable z is shared across all models, and the models are jointly tuned in a mirror fashion. That's why it's called Mirror-Generative Neural Machine Translation. They jointly tune using a parallel or a non-parallel corpus. And so you're learning all the models simultaneously to get those models trained, and then you can use them for your translation purposes. And the idea is, you can exploit non-parallel data in this way by using these language models, but also you can, through this shared variable, you could kind of allow the models to share some of the knowledge learned by the different models, and in this way improving the overall performance for all models. So another representation is given in this figure here, where you have your source and your target and your latent variable z, and you're learning models linking all of those components together. And here you also have a graphic of this, the same as what I was talking about, where you have again source target and you have all of your models which are connected using this latent variable z. Right, so actually the implementation is of this is a bit complex. It involves a lot of math. So I will not go into details here. You can check out the paper and read more if you're interested in. But I wanted to give you some intuition of how well this works in practice by showing you the experiment. They actually perform quite a lot of experiments on both low resource translation and high resource translation. So low resource where you have little parallel data to start with, and then you add non-parallel data, and then high resource where you have a big parallel data set to start with. They test, actually maybe I should mention that this mirror-generative neural machine translation is model agnostic, so you could plug in your transformer architecture or your RNN if you're interested in that. Yep. So just to show you some experiments on this. Here we have low resource results on WMT English to Romanian dataset, as well as IWSLT English to German. Just to do cross domain. I'm not actually sure what precisely they mean here, but so here you have the results of a transformer baseline trained on this parallel English to Romanian dataset, and you have also a bunch of baselines. Like generative neural machine translation is taking a similar approach, but it's not doing the mirror step. So it's only doing a thing. It's only integrating a language model and having a shared latent variable between the language model and the source to target model, but there's no reverse model, target to source model. That is the main difference. But here is the MGNMT model without parallel data in addition, only the parallel data set and using the non-parallel data. And what you can see is that already without the parallel data you're getting an improved performance in terms of this blue metric, which is nice because it seems to be indicative that the source to target and target to source and language models are capable of perhaps, hopefully, collaborating and sharing the knowledge indeed across this latent variable z. And when you add some non-parallel data, you're getting an improved performance over the baseline without non-parallel data. Here you're also getting, I'm not sure about those, so I'm going to skip that one. But if we go to the results on resource-rich languages, which is English to German, German to English, English to Chinese, Chinese to English, you again see that the baseline MGNMT is outperforming the transformer, as well as the baselines, and with non-parallel again you're getting some improvements, which is nice to see, and this seems to hold even for Chinese as well. So distance language pair translations from English to Chinese and Chinese to English. So I think that was the main things that I wanted to discuss. You have a lot of other experiments and analysis in this paper, and there's a lot of details. Here they also show that it seems that they show some further proof that this step of mirror training seems to perform better than compared to some previous work on integrating language models within translation, pre-trained language models from this paper here. And yeah, so it seems to be a really interesting and effective approach for training the source to target to source models jointly in a very interesting way, which seems to be effective, and then also a very nice way to add additional pseudo-parallel data, or not pseudo-parallel but non-parallel data within your translation models to get an even improved performance. So thanks for watching, and talk to you next time.